Renowned English scientist Sir Isaac Newton wanted to understand the world better. He thought he could describe the movements of the universe through mathematical observation. In 1687, he published these observations in a book, which outlined his understanding of the laws of motion. These 3 laws of motion are still in use today and can help us understand the relationship between a body and the forces acting on it.
Let me discuss to you what is law of inertia. Law of inertia is the first law of Newton's law. It states that a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. The materials that we need to use are a coin, a cardboard, and a cup. The coin has enough inertia to resist the moving of the paper, so the gravity that acts upon it and it falls to the bottom of the coin. In this case, the gravity is the force that is acted upon the coin. Due to the movement of the paper, the gravity enables the coin to fall inside the cup.
Let me discuss to you the second law of motion, which is the law of acceleration. The formula of law of acceleration is force is equal to mass times acceleration, where F is the net force, M as the mass of the object, and A as the acceleration. The unit for this formula is Newton. It is concise and sufficient statement of Newton's second law of motion. In vector form, it shows that acceleration and applied net force are parallel vectors. Keeping the mass constant demonstrates a direct proportion between acceleration and the applied net force. Keeping the force constant demonstrates an inverse proportion between acceleration and mass.
The materials that we need to use is a piece of cardboard or anything that is available for the barrier of the jaw lens. The next one is the jaw lens. For the first part, place the marbles on an inclined plane, then place the cardboard in front of the marbles. To put the experiment into action, pull the cardboard. You will notice how the marbles are moving at the same speed. This is due to the factor that affects the acceleration. 1. It is because of the weight of the marbles. In the formula given, it is shown that the acceleration is directly proportional to the force, and it is inversely proportional to the mass of the object. And for the last law of motion, which is the law of interaction, it states that when one body exerts a force on the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body.
We will now have Newton's third law of motion, which is the law of interaction. Our activity is hitting the wall with our fist. This is the wall I am going to
on a chair. Because when we sit on a chair, our body exerts downward force in the chair. So the action, the chair also exerts upward force to the body. The reaction there is if the chair would not have exerted force, the chair would collapse and we would not able to sit on the chair. And for the last example of law of interaction is this. The force that she applied on her hand is now equal to the force that her face received.
The law of interaction says that when one body exerts a force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. To sum up the three laws of motion, the first law, which is inertia, states that an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless it is acted upon an imbalanced force. And for the second law of motion, which is the law of acceleration, it states that an inertial frame of reference, the vector sum of the forces on an object is equal to the mass of the object is multiplied by the acceleration of the object.